Now we will discuss the body projected from top of tower. From top of tower. For example, you're taking a tower of height h. So this is a tower of height h, and you are projecting a body. You are projecting a body upwards. After traveling for some time, again it returns back to the ground. So this is very important. Out of all vertical projected body models, this is very important. You are projecting a body with a speed u. So may it reaches the ground in a time t we are taking. So then we used to think of acceleration. Already we have taken that acceleration. Suppose if we are taking in two-dimensional, this is x and this is y. So acceleration equivalent, as the body is moving upwards, we will take minus g, and as it is moving along y-axis, we are taking j cap. And this is the initial position, and this will be the final position. So this is the displacement. The displacement lies in downward direction as you are taking. As it is along the downward direction, we will take this as s bar is equivalent to h into, as it is along negative y-axis, we are taking minus j cap. So now we will apply this is equivalent to ut plus half a t square in vector form, u bar into t plus half a bar into t square. S bar is equivalent to h into minus j cap we are writing, and u bar equivalent to, as it is projected upwards, we are taking u bar equivalent to u into j cap. U into j cap, u into j cap into t plus half into minus g into j cap into t square. So we are cancelling that j cap. Therefore, we will get minus h is equivalent to u into t minus half dt square. Or we can write it as h is equivalent to minus ut. We are multiplying with minus and hold the equation. We get h is equivalent to minus ut plus half dt square. So this is very important relation. This is very famous. So generally on vertically projected body, out of all models, this one is very important. Or simply we will understand this in another form. For future reference I am taking. So h is equivalent to minus u means the body is projected in y direction. So therefore I am taking minus uy into t plus half dt square. So we can take in this format also, but this format is not useful right now here. So this is useful in motion in a plane. So actually this formula is useful in motion in a plane. So this is useful in motion in a plane. So only you have to confine up to h is equal to minus ut plus half dt square. Okay. So we are taking some examples over motion under gravity. So that is freely falling and vertical projected body combined. Suppose we are taking a body falls freely from a height. A body falls freely from a height of 125 meters, where g equivalent to 10 meter per second square. After 2 seconds, gravity ceases to act. Gravity ceases to act. Find the time taken. Find the time taken by it to reach the ground. Find the time taken by it to reach the ground. First, before taking any physics problem, we need to analyze that problem. Okay, so first we will see how to analyze the given data. So first I'm reading. A body falls freely. Body falls freely means simply we will say that initial velocity equal to 0. So therefore this is a freely falling body. And from a height of 125 meters means this is h is equivalent to 125 meters. After 2 seconds, so we are taking the first time, the gravity ceases to act. So ceases means stopped. Ceases means stopped to act. Stopped to act. So we need to construct a diagram. For example, I'm taking this is a tower of height 125 meters. This is a tower of height 125 meters. You're starting a body freely from here. So actually, it covers some distance for 2 seconds. The 2 seconds is given as first time interval. For 2 seconds, it may cover the distance S1. Let us say this will be S1. So first I am estimating the distance. S is equivalent to half gt square for freely falling body. So therefore, g means 10 by 2. C1 means 2 square. So that equal to 5 4 ja 20 meters. 5 4 ja 20 meters. So that means in the 2 seconds, it covers a distance of 20 meters. So then it has to cover a distance of S2, let us say S2 equivalent to 125 minus 20 meters. Okay. But after covering 20 meters, so definitely there is no gravity. There is no gravity means no acceleration. No acceleration. No acceleration means velocity is constant. Velocity equal to constant. అంటే ఇక్కడ 2 seconds దగ్గరికి ఎంత వెలాసిటీ వస్తుందో 2 seconds వరకు ఎంత వెలాసిటీ వస్తుందో అదే వెలాసిటీతో ఇది కంటిన్యూ అవుతుంది. ఫస్ట్ we will find out the velocity of a freely falling body. Velocity of a freely falling body here, right? Already we know the principles. V equivalent to gv1, that equal to 10 into 2, so that equivalent to 20 meters per second. So that means again it's going to continue its journey with constant velocity 20 meters per second. So when the body is moving with constant velocity, the distance covered, again we are writing S2 is equivalent to u2 into t or ut plus half at square. So initial velocity for the second segment, this is the initial velocity. That is nothing but we can call it as v20 into time means we need to calculate. Time means we need to calculate plus acceleration equal to 0 because the velocity is constant, acceleration equal to 0, and S2. So this is nothing but we are going to see it as 105. Suppose if you take the time as t2, so therefore t2 is equivalent to 105 by 20, that equivalent to 5.25 seconds. But we need the total time. So when we need total time, so that is nothing but t1 plus t2. So t1 means 2 seconds and t2 means 5.2 seconds. That equivalent to 7.25 seconds. In this way, we need to understand. So again, we will discuss this. So ఎలా ఆలోచించాలని నేర్చుకుందాం. First started from v equal to 0. Okay. After 2 seconds or in this 2 seconds, it covers a distance of 20 meters. అది మనం s equal to half gt square వరకు మనం చేస్తాం. ఇప్పుడు క్వశ్చన్ ఏంటి అంటే ఈ రిమైనింగ్ డిస్టెన్స్ ని ఎంత టైంలో ట్రావెల్ చేస్తుంది అనేది క్వశ్చన్. మనకు డిస్టెన్స్ కావాలి అంటే ఉన్న ఒకే ఒక ఫార్ములా s equal to ut plus half gt square. సో ఈ సెగ్మెంట్ కి ఇనిషియల్ వెలాసిటీ కావాలి. ఈ సెగ్మెంట్ కి ఇనిషియల్ వెలాసిటీ ఏమవుతుంది? ఫస్ట్ సెగ్మెంట్ అది ఫైనల్ వెలాసిటీ అవుతుంది. So ఇప్పుడు నేను ఫస్ట్ సెగ్మెంట్ కి ఫైనల్ వెలాసిటీ చేశాను v equal to gp1. So that will become the initial velocity for the second segment. So when there is no acceleration, so simply we will take a equal to 0. Already by subtracting 20 from 125, we got the s2 as 105. So 105 equivalent to 20 into t2 అంటే t2 మనం ఫైండ్ అవుట్ చేయొచ్చు. సో టోటల్ టైం అంటే t1 ప్లస్ t2 ఇక్కడ మనం తీసుకుంటాం. సో ఇంకొకటి ఏంటి అంటే ప్రతి ప్రాబ్లం మనం చదివేటప్పుడు మనకు కొన్ని కొత్త కొత్త వర్డ్స్ వస్తూ ఉంటాయి. సో నేను వాటిని అండర్లైన్ చేసుకోమంటాను, అంటే రాసుకోమని చెప్తూ ఉంటాను. సో యూ నీడ్ టు నోట్ దట్ పారామీటర్. సో టేక్ ఏ బాక్స్, ఐ యూజ్ టు కాల్ ఇట్ యాజ్ బబుల్ బాక్స్. సో ఇందులో ఈ ప్రాబ్లం నుంచి నువ్వు కొత్తగా ఏం నేర్చుకున్నావు అనేది అర్థం చేసుకోవాలి. సీజెస్ అనేటువంటి వర్డ్ మనం చూసాం. సీజెస్ అంటే గ్రావిటీ సీజెస్. గ్రావిటీ సీజెస్ అంటే మనం ఏమో అర్థం చేసుకోవాలి అంటే యాక్సిలరేషన్ ఈక్వల్ టు 0 అనేది అర్థం చేసుకోవాలి. సో ఇలా మనం ప్రతి ప్రాబ్లం మనకేం నేర్పిస్తుంది అనేది ఆలోచించాలి. సో అప్పుడు మనకు ఫిజిక్స్ చాలా ఈజీ అవుతుంది. నెక్స్ట్ వీఆర్ టేకింగ్ అనదర్. A parachutist drops freely from an aeroplane for 5 seconds. Or let me take that 10 seconds. For 10 seconds before the parachute opens out. Before the parachute opens out. Then he descends with a net retardation. He descends with a net retardation of 2 meters per second square. Of 2 meters per second square. His velocity when he reaches the ground. When he reaches the ground is 8 meters per second. Find the height. At which he gets out of the aeroplane. He gets out of the. So first you need to analyze the question. Drops freely. So that means initial velocity equal to 0 for 10 seconds. This is the T1 before the parachute opens out. So that means this is the parachute. So it will act as a freely falling body for 10 seconds. T1 equivalent to 10 seconds. So means it gains some velocity. Let us say v1. Let us say v1 equivalent to gp. And of course g is not given actually. So therefore, as it is not given, by default we will take it as 9.8 meters per second. 9.8 into 10, that equivalent to 98 meters per second. So that means in the 10 seconds, it gains a velocity v1, and during the 10 seconds, it covers a distance s1. So let us think of s1 is equivalent to half gp square. So that equivalent to half into g means 9.8. So t1 square means 10 square we are taking. So that equivalent to 4.9 into 100, 490 meters. So now we need to understand the question. Now the parachute is opened. The parachute is open now, and it is not having gravity right now. It has a retardation of 2 meters per second. Retardation means negative acceleration. From now onwards, it has retardation. When he reaches the ground, his velocity is 8 meters per second. So that means, suppose here the person gains a velocity v2 equivalent to 8 meter per second. So when the parachute bails out, opens out, he may cover the distance, yes. He may cover the distance, yes. So we have initial velocity v1, final velocity v2, acceleration a, and yes. So therefore we need to think of v square minus v square equivalent to 2a. So final velocity is nothing but 8 square minus initial velocity is nothing but v1. So v1 is nothing but 98. We are writing. So that equivalent to 98 whole square. That equivalent to 2 into acceleration is nothing but minus 2. That is retardation into s. So by solving that, around we get 2385 meters, let us say. But the question is, we need to find the total height. So total height means that is nothing but s1 plus s2. We need to find. S1 is nothing but 490 plus S2 is nothing but 2385. So finally, we are going to get it as 2875 meters. 2875 meters. So ఇక్కడ క్వశ్చన్ ఎలా అనలైజ్ చేయాలో ఒకసారి చూద్దాం. ఫస్ట్ పారాచ్యూట్ అనేది ఓపెన్ అవ్వలేదు. పారాచ్యూట్ ఓపెన్ అయితేనే దాని ఏరియా పెద్దగా ఉంటేనే అపోజింగ్ ఫోర్స్ అనేది ఉంటుంది. సో until then the parachute will behave as a freely falling body. So therefore we have discussed the distance covered s1 for a freely falling body as half the square and velocity as v. ఇది కనుక్కున్నాం. నెక్స్ట్ ఏం ఏంటంటే ఇక్కడ నుంచి ఫ్రమ్ హియర్ I hope you are able to see my hand. From here the parachute opens out. From here the parachute opens out. When the parachute opens out, it has retardation. It has air opposition. So because of that, it was not traveling with gravity. It was traveling with a retardation. Retardation means negative acceleration, minus 2 meters per second square. And finally, it remained with a velocity. It reaches the ground with a velocity 8 meters per second. ఇక్కడ చూడండి, ఈ సెగ్మెంట్ కి ఇది ఇనిషియల్ వెలాసిటీ అయితే ఇది ఫైనల్ వెలాసిటీ అవుతుంది. ఇది యాక్సిలరేషన్, ఇది డిస్ప్లేస్మెంట్. So simply we will say v square minus v square equal to 2a for the second segment. This is the second segment we are taking. So for that one we are calculating s2 as 2385 meters. The total height ante, so the height, the distance before bailing out the parachute, before opening the parachute, and after opening the parachute. We need to add those two values. So we will get s1 plus s2. By adding those two, we will get around 2815 meters. So first we will analyze the question. If a freely falling means initial velocity equal to 0, covers half of its total distance. Covers half of its total distance in the last second. We know that last second means yes. Suppose if we are taking s is the total distance covered. S is the total distance covered. So then we will always think Sn is nothing but the distance covered in nth second or the distance covered in last second. So in the last second, it covers half of the total distance. That is Sn is equivalent to s by 2. Sn by s is equivalent to, we have a shortcut. So 2n minus 1 by n square. So Sn by s is nothing but 1 by 2. So that equivalent to 2n minus 1 by n square. So that is n square equivalent to 4n minus 2. N square equal to 4n minus 2. N square minus 4n plus 2 is equivalent to 0. So simply this is an algebraic equation. We will write it is in the form of ax square plus bx plus c is equivalent to 0. So therefore x is equivalent to minus b plus or minus root over b square minus 4ac by 2a. Minus b means minus of minus 4 plus or minus root of b square means 16 minus 4 into acceleration means we will take 1 and c is nothing but 2. X is nothing but we are taking the value of n. Minus into minus means 4 we are having plus or minus. Root of 16 minus 8 means 8 by 2 into a means 1. Or finally we have 4 plus or minus. I'm expanding the root 8 as to root 2 by 2. So finally we have by dividing it to 2 plus or minus. But n is nothing but the last second. Last second means, so definitely n should be more than at least 1. ఒకటి కన్నా ఎక్కువ ఉండాలి కదా. So 2 minus root 2 is not possible. 2 minus root 2 is not possible actually. 2 minus root 2 is not possible. So therefore the possible value is n equivalent to 2 plus root 2. N equivalent to 2 plus root 2 we are taking. A balloon starts from rest. So means initial velocity equal to 0. Moves vertically upwards with an acceleration of 3 by 8 meters per second. Now a stone falls from the balloon. First balloon gurinchi alochiddam. Suppose a balloon starts from rest, so that is u is equal to 0. It was moving vertically upwards for 8 seconds. So t equivalent to 8 seconds it travels. So that means it gains some velocity v, let us say. So v equivalent to u minus gt we are having, body moving upwards. So u is 0 minus g. Actually acceleration is given. So therefore we will take u minus at, that equivalent to minus g by 8 into t. T means 8. T means 8. So therefore v equivalent to that equivalent to, or you may take it as u plus 18, no issues. So v equivalent to g meter per second square. V equal to u plus 80 Rasan. Body is projected with some zero velocity. So after some time, 8 seconds, it gains a velocity g meter per second square. A stone falls from the balloon after 8 seconds from the start. Further time to reach to the ground. So we need to consider in the 8 seconds, actually the balloon travels some distance here. So first we will find out that distance. We will find out that distance. So that is s is nothing but we will write ut plus half at square. So s is nothing but initial velocity equal to 0 plus half into acceleration is g by 8 and time is this is 8 seconds, 8 whole square. So that equivalent to g by 16 into 64, that equivalent to 4g meter. 4g meter. So that means the balloon after traveling for 4g height, so the stone is inside the balloon only. The stone is inside the balloon only. So whenever the stone leaves the balloon, so the stone, it travels sometime upwards and again it will fall onto the ground. అంటే ఇక్కడ ఒకసారి క్వశ్చన్ ఏంటో ఒకసారి అన్నది చెప్పండి. బెలూన్ రెస్ట్ నుంచి స్టార్ట్ అయ్యి 8 సెకండ్స్ ట్రావెల్ అయిందంట. సో 8 సెకండ్స్ ట్రావెల్ అయ్యేసరికి దీని వెలాసిటీ అనేది ఎంత వచ్చింది అంటే g మీటర్ పర్ సెకండ్ స్క్వేర్ వచ్చింది. ఇప్పుడు దీంట్లోంచి సడన్ గా ఒక స్టోన్ బయటకు వస్తే బెలూన్ కి ఎంత వెలాసిటీ ఉంటుందో స్టోన్ కూడా అంతే వెలాసిటీ ఉంటుంది. స్టోన్ బయటకు వచ్చిన తర్వాత స్టోన్ ఇలా పైకి వెళ్ళి మళ్ళీ కిందకి వస్తుంది. ఎందుకని అంటే స్టోన్ కున్న మొమెంటమ్, స్టోన్ కుండే వెలాసిటీ, బెలూన్ కుండే వెలాసిటీ రెండు సేమ్ అవుతుంది కాబట్టి స్టోన్ దాని వెలాసిటీ 0 అయ్యేంత వరకు పైకి వెళ్ళి మళ్ళీ కిందకి వస్తూ ఉంటుంది. అంటే ఇక్కడ ఈ ప్రాబ్లం అనేది మనం ఎలా ఆలోచించవచ్చు అంటే బాడీ ప్రొజెక్టెడ్ ఫ్రమ్ టాప్ ఆఫ్ ఏ కవర్ లాగా ఈ ప్రాబ్లం మారింది. ఇది 4g అయింది. అండ్ ఇనీషియల్ వెలాసిటీ అనేది మనం తీసుకున్నాము g అని రాస్తున్నాం. యాక్చువల్లీ బాడీ ప్రొజెక్టెడ్ ఫ్రమ్ టాప్ ఆఫ్ టవర్ అంటే ఫార్ములా మనం ఇందాక చదివాం. h is equivalent to minus ut plus half g square we are writing. h is nothing but height, that is 4g, equivalent to minus initial velocity is nothing but g into t plus g by 2 into 6 square. So we are eliminating g, we get 4 equivalent to minus t plus t square by 2, or 8 equivalent to minus 2t plus 6 square, or we get t square minus 2t minus 8 equivalent to 0. సో దీన్ని మనం రూట్ చేయవచ్చు. AC is equivalent to 8 రావాలి. సో t square minus 4t plus 2t minus 8 is equivalent to 0. By solving this, we will get t equivalent to 4 and t equivalent to minus 2 seconds. Actually, this is not possible. So therefore, our option is t equivalent to 4 seconds. Our option is t equivalent to 4 seconds. So first we will analyze the question. The distance traveled by a body projected upwards during last second of its journey. For example, you are projecting a body vertically upwards. Maybe you are projecting a body with a speed u in the last second of its journey. So this is the last second. So this distance is d. సో మనం లాజిక్ చెప్పేటప్పుడు చెప్తున్నాం, ఎప్పుడు డిస్టెంట్ లో అడిగితే మనం అసెంట్ లో చూసుకోవాలి. అంటే ఇప్పుడు లాస్ట్ సెకండ్ లో డిస్టెన్స్ ఏమవుతుంది అంటే ఫస్ట్ సెకండ్ లో డిస్టెన్స్ ఎంత ఉంటుందో లాస్ట్ సెకండ్ లో కూడా అంతే. సో దేర్ ఫర్ d is equivalent to the distance covered in first second of upward motion. d equivalent to ut plus half u square వాడచ్చు. u into t means 1 plus half into acceleration means minus v, t means 1. So therefore d equivalent to u minus v by 2 we will get, or u equivalent to d plus v by 2. Now analyze the question again. If the velocity of the projection is doubled, this is another case. You are taking bodies projecting with double the velocity. So then the distance traveled by the body during last second of its upward journey. During last second of its upward journey. So this is the distance. This is the last second. So this is the last second of upward journey. సో ఇలా ఉంటే ఎప్పుడు మనము లాజిక్స్ లో నేర్చుకున్నాం, LHS అడిగితే RHS చూసుకోవాలి, అసెంట్ లో అడిగితే మనం డిస్టెన్స్ చూసుకోవాలి. ఇది లాస్ట్ సెకండ్ అంటే ఈ RHS మొత్తం ఫ్రీలీ ఫాలింగ్ బాడీ అని మనం నేర్చుకున్నాం. సో దిస్ ఇస్ ద డిస్టెన్స్ కవర్డ్ ఇన్ ఫస్ట్ సెకండ్. సో డిస్టెన్స్ కవర్డ్ బై ఫ్రీలీ ఫాలింగ్ బాడీ is g by 2. So our required answer is g by 2. Our required answer is g by 2. Let us analyze the question. Body is thrown vertically upwards with initial velocity u, reaches a maximum height in 6 seconds. So that means that this is the body projected upwards. It reaches maximum height in 6 seconds. So therefore, the total time of ascent is 6 seconds. The ratio of distance covered in first second to the 7th second we are taking. So this is called as first second. This is called as first second. So up to here it takes 6 seconds. So therefore, so during the downfall, the first second is nothing but, now this will become 7th second. Now this will become 7th second. So this is the 7th second. So we are continuing the discussion. Actually, we know that. So the downfall journey is nothing. Downfall journey means RHS is nothing but freely falling body. So the freely falling body covers. We know that time of ascent equivalent to time of descent also. In the 6 seconds we are taking. So that means we need to take 6 parts. 1, 2, 3, 4, 5, 6. So this is the distance covered in 7th, 8th, 9th, 10th, 11th, 12th. But we know the RHS is the distance is covered by a freely falling body. G by 2, 3G by 2, 5G by 2, 7G by 2, 9G by 2, and 11G by 2. Or simply we will take it as 1:3:5:7:9:11. Now understand the question. So the distance covered by the body in first second to the distance covered by the body in 7th second. సో లుక్ ఎట్ హియర్. సో ది డిస్టెన్స్ కవర్డ్ ఇన్ ఫస్ట్ సెకండ్ అంటే ఎల్హెచ్ఎస్ అడిగితే ఆర్హెచ్ఎస్ చూసుకుంటాం మనం తెలియకపోతే. అంటే అది ఎంత అవుతుంది? డిస్టెన్స్ కవర్డ్ ఇన్ ఫస్ట్ సెకండ్ ఈజ్ 11 g/2 అండ్ ది డిస్టెన్స్ కవర్డ్ ఇన్ 7 సెకండ్స్ అదే తెలుసు మనకు. కాబట్టి ఇక్కడ ఏం రాస్తామంటే g/2 అని మనం తీసుకోవచ్చు. సో దట్స్ వై సింప్లీ వి విల్ టేక్ 11 ఇది షార్ట్ కట్ యొక్క బ్యూటీ అన్నమాట.